Welcome to Texas State University's Chemistry 2330, Introduction to Organic Chemistry. I'm your guide, Dr. David Irvin. We will begin with Chapter 8, Part 1, Alcohols, Ethers, and Thiols. Okay, now we're going to introduce a new functional group called the alcohol functional group. And the primary thing that makes it an alcohol is the fact that we have an OH, or a hydroxyl group, bound to an sp3 hybridized carbon. Note that the oxygen is also sp3 hybridized. The lone pairs take up two of the electronic positions, giving us our bent molecular structure. Okay. You must have the hydrogen on the oxygen to have an alcohol. If we were to bond that oxygen to another carbon, that becomes a different functional group I'll talk about in a minute, called an ether. When we name these things, alcohols are the functional group that actually will change the name of the parent. And so what we will do is we'll take the longest continuous carbon chain that contains the OH group, and then we will take that number and drop the E at the end and add OL to it. So if we had hexane and we added an OH to it, it'd be hexanol right there. If we wanted to name it with a common name, we just name it for our common alkyl name, like hexyl or methyl, and add the word alcohol to the end. So let's do a couple of those so we can get the hang of this. So if we were to name this first compound with the IUPAC name, we have two carbons, so it's ethyl. So it'd be ethane, but we have now the alcohol, we drop the last E and add OL, so it's ethanol. Okay, the common name would be the fact that we have two carbons, which would be an ethyl group. Therefore, we have ethyl alcohol. Okay, let's jump over here to this one on the end here, right here. We have 1, 2, 3, 4 carbons. So that gives us butane, but we have an alcohol on the end. So we have to show that the alcohol is on the one carbon. So we have 1 butanol for our name. That's our IUPAC name. For our common name, we name it for the 4-carbon group, which is the butyl group, and then the word alcohol. Okay, so now let's do this last one here. And what we have is our longest parent chain is only 3 carbons long, and then there's 1 substituent plus the alcohol. Okay, so we have to name it for our longest parent chain of 3 carbons, which would be propane. Drop the E at the end, add OL, so it's propanol. And now, because we're naming it for the alcohol, it has to have the lowest number. So we're going to call this 1, 2. So that makes it 2-methyl, 1-propanol. Notice if we have that long chain and the alcohol is not on the end, we have to name number where it is. So in the case of this derivative of butanol, this is 1-butanol because the hydroxy is at the end of the chain. But because our longest chain is still 4 carbons long and we're naming it for the alcohol, we have to go 1, 2 carbons over, so it becomes 2-butanol. However, that group is also known as the sec-butyl group, and so the common name is the sec-butyl alcohol. Okay, so you can have more than 1 hydroxy on a compound, and when you do, you can call them diols, and when you have 3, you can call them triols. Just like you can have a trichloro compound, it would be a triol. So in this case, you would name the parent compound, keep the E on the end, and add it whether it's diol or triol. So in the case of this 3-carbon chain, we would have propane, and we have 1 alcohol on 1 carbon and 1 alcohol on the 2 carbon. So we have 1, 2, propane diol. And if it gets longer, if we have 3 on there, we would name it 1, 2, 3, propane triol. Okay, now comes the last most complicated rule, and what we call it is the enol rule. So if you have an unsaturation, a double bond or a triple bond in there, you have to say that it's not an alkane anymore by having the en or the yn in it. So in this case here, we have 1, 2, 3, 4, 5, 6 carbons, but we have a double bond in the middle here. So we have to take into account that we have 6 carbons and a double bond, which gives us hexene. Okay, But we also have an alcohol. Alcohol also changes the name. So we need to call it hexene-all, okay? But that doesn't tell us where all the double bonds are and where the alcohol is. So naming the first substituent at its lowest level, which would be this right here, we're going to make this the 1-all, and that goes over 1 carbon, 2 carbon, 3 carbon. So the double bond starts on the 3 carbon. So now we have 3-hexene 1-all. We're not quite done there. We have to figure out whether it's cis or trans. Because we only have 2 substituents, a trans 3-hexene 1-all is appropriately named. Or if you want to do prioritization, we have the 2 carbon and the 5 carbon are their priorities. They are on opposite sides, which makes them Engagen. So it would be E, 3-hexene 1-all. Okay, so if we take that hydrogen off and add another carbon bond, so we have a carbon-oxygen-carbon bond, we now have a different functional group, and it's called the ether group, okay? And because the carbon, the oxygen is still sp3 hybridized, the 2 lone pairs take up space, giving us that bent configuration of approximately 110 degrees. When we name ethers, we actually name the longest parent chain that goes up to where the oxygen bond is, and then the oxygen and the shorter chain is named as a substituent. The name ether does not change it in our UPAC rules. However, we do use it in common names. So in the case of this right here, we have an ethyl group plus a substituent. And so we would call this substituent the ethyl oxy, for having that oxygen be an ether, ethane. So we have our longest chain, and they happen to be symmetrical, so it's okay here. So, but in the case of common names, because we have 2 ethyl groups, we can call it diethyl ether. If we did it slightly differently, so we had a methyl ethyl group here, we would have the longest parent chain be the ethyl, and then this would be our substituent as the methoxy. So we'd call this methoxyethane. In common names, we'd name each of the alkyl groups first. So it'd be ethyl methyl ether. Okay. And then of course we can continue on our nomenclature here and continue. And if there are 4 substituents, we have to worry about R and S. And if it's a ring, we have to name it for the ring. So in this case here, the alcohol changes the parent. The parent is the cyclohexane, but it has the OH on it, so that makes it cyclohexanol. Our ether is its substituent, and it's 1 carbon, it's the 2nd carbon over, so that makes it 2-ethoxy cyclohexanol. And then of course we assign the R and the R to the 2 chiral centers. Okay, we can also have what we call cyclic ethers. These are ethers where we have a carbon chain and the oxygen closes the ring. These are really commonly used as solvents because of their low reactivity. But there is one very reactive species, is this one right here. We call it ethylene oxide, or occasionally it's called an epoxy. This is used because it's a strained ring and it reacts because it opens up. But most of the other ethers like this, the THF or tetrahydrofuran, are used as chemical solvents because they are resistant to chemical reactions. The last function group I want to talk about in this chapter is what we call the Thyle group. And it's basically a sulfur that has a hydrogen on it, so it looks like a sulfur alcohol. We call that a thiol. And just like with oxygen, it still has 2 lone pairs, so electronically it's tetrahedral and sp3 hybridized, but it has that nice bent configuration with the hydrogen. Okay. When we name these, thiol becomes the parent chain, so we name the longest alkyl chain plus thiol. If it's a common name, we name it for the alkyl group like isopropyl or captan. Alternatively, we can use it if there is something else of higher priority, like a carboxylic acid or a ketone. The thiol acts as a substituent, and we call it a mercapto substituent on whatever the parent chain becomes.